This unit is going to be on polynomials, and that might sound like a big word, and we're going to actually start out with monomials. But the thing that's really good about what we're going to be doing in the next few days in particular is this is an area that kind of overlaps stuff that we've already learned. But it's really important. In fact, it's so important that we're going to spend the next few days on it, because if you don't have the concepts we're talking about here in the next day or so, then it's going to really cause you problems when we kind of expand and introduce you to the world of polynomials. So it's really important that you have the fundamentals down. And like I already mentioned, as you're copying down these parts of the notes and leaving places for blanks, the good thing is that it overlaps. In many ways, we've seen most of this before. I even have had you do an IXL on what we're doing today before, but only two had actually mastered it. So that's also kind of will help you know that us going over it again, it's going to be pretty important. Well, let's start out with just some very brief definitions and defining a few things so we understand what we're talking about. So what you've written down, first of all, is that a monomial now that might be a new word, but you really know what a monomial is. A monomial, it's made up of a constant. Now, that's the math word for just a number. It's also made up of it could be made up of a variable. So it could be a number or a variable, or a monomial could be both. It's what we've talked about in the past as a term. It really is the same thing. So we talked about terms earlier, and a monomial is just a single term. Well, let me give you just some quick examples of a monomial. A monomial can be a number, 3. It could be a -7. Those are just single numbers. Those each could be monomials. It could be 3x. We've got a number and a variable. Not very complicated, is it? It could be just a variable, or a couple of variables. It could be 5xy squared. All those are monomials. Mono meaning one. Polynomial means multiple terms or multiple monomials. But what we notice is that it does not have any addition or subtraction. Let me show you. This is not a monomial. And it looks pretty obvious. If I said x plus 3y, that's two terms, right? And so that's not a monomial. A monomial is just a single term with a constant, a variable, or both. It can be positive or negative. This is the part where what we've already learned overlaps to add or subtract monomials. All we have to do is add or subtract what we've already identified as like terms. We've talked about that already. And we know that if their terms are alike, meaning that they have the same variables with the same exponents, they're like terms. Just to make sure that we know what like terms are monomials. I'm going to turn it around and word it just a little differently. Monomials with the same variable and same exponents are what I just said, like terms. So if they've got exactly the same variable and that variable has exactly the same exponent, then they're like. If it has different variables, they're not like. Like terms can be xy and 5xy. Both xy and 5xy are like terms because the variable portion is exactly the same. Or if it were, say, 7st squared, if the other term has a 7, doesn't have to be 7, it could be a 5, but the st squared part is the same, those are like terms. So all we have to do to add or subtract monomials is to add or subtract like terms. So that's the overlapping portion of this lesson. We know how to add and subtract like terms. So when we're talking about monomials, that's what we do. And whatever we do, when we add or subtract, we do not change the variables or the exponents when adding and subtracting. We'll want to look at what that looks like in the way that we'll find it in an example here and some of the practice that you'll need to be doing today. So I'm going to give you 6 quick examples. We'll kind of roll through those pretty quickly. And like I said, the video will be on today's lesson, and you can go back and watch it if you have questions. So let's look at the first example. In this first example, we've got 13w squared plus 9w plus 4w squared minus 31w. So what I'm going to do is I'm just going to simply identify like terms. So 13w squared will go with 4w squared, And 13 plus 4w squared is 17w squared. Can't mix that up with the w, so I'm going to look at the w's here. I've got positive 9w squared, but positive 9w squared, minus 31, and those two go together, and that's a negative 22w. All right, so there's my w squared. With 9 and negative 31, that one was positive, the other was negative, so I had to subtract. I can't subtract 17w squared and 22w because one's a w squared, the other is not. Let's look at the second example. All right, so this one is 10m squared n plus 7m n squared minus m squared n. One of the things I'm going to do just to help us keep clear is I'm going to go ahead and put a coefficient in front of m squared n. That coefficient is always 1. We don't have to write it because we know it, but I'm going to put it in there just to help us stay clear. I have a term that is m squared n and another one that's m squared n, but this one's m n squared, so it's not a like term with the others. All right, so it's 10m squared n minus 1m squared n. That's going to be 9m squared n plus 7m n squared. Can't do anything with that one. Can't add it because those are not like terms. That's my answer. For number 3, I want to find the sum. What does sum mean? Yeah. So that's going to be add of 16y squared and negative 5y squared. So I can find the sum. I can go ahead and actually add those two because they are like terms. If they weren't like terms, all I could do is say, well, this one plus that one. But since they're like terms, positive 16 and negative 5 will give me a positive 11. One's positive, the other negative. I have to subtract them. And I don't change the variable portion, so my answer there, 11y squared. If I asked you to find the difference, what does difference mean? Yeah, subtract. All right, so if I want you to find the difference of 10x squared y and 2x squared y, now you got to be careful here. Difference means to subtract, so this becomes 10x squared y minus 2x squared y. Well, they're like terms, so I can go ahead and do the next step here. The next step will be 10 minus 2 is 8, x squared y. Can only do it if they're like terms. Slip number 5. Want to subtract (9a) from negative 15a. See how sharp you are. When I say subtract 9a from negative 15a, which comes first? Yeah, negative 15a, that's sharp. Because I'm taking it from that one, so I have to start with that one. So negative 15a minus 9a. Now, it's a little tricky in that my signs are the same. They're both negative, so I know the rule is I add. So it's going to be a negative 24a. Questions? Last example, number 6. From, I'll word this one a little differently, from negative 9c d squared, subtract negative 2c d squared. Which comes first? Yeah, negative 9c d squared. And I'm going to subtract, here's my subtraction sign, the negative 2c d squared. Now, I know that when I have double negatives, I replace that with an addition sign, so it's really negative 9c d squared plus 2c d squared. Negative 9 plus 2 is negative 7c d squared. The c d squared part does not change. So really, when I'm adding, subtracting monomials, all I'm doing is what I've already know to do, which is to combine like terms. That gets me started working with monomials.